All right, section 2.4, looking at dividing polynomials and doing remainder and factor theorems. So got some information here in the beginning. We're going to basically go back to like dividing like when you were younger, like doing some long division, but I'm also going to teach you another way that you can do it, which is called synthetic division. It says you will have to demonstrate both. All right, for our purposes, we'll only use synthetic division if the polynomial we're dividing by is linear. Linear means that the highest power is 1, okay? So that's kind of a key thing there. But really, I'm not going to read through all of this stuff. Mainly, I'm just going to jump right in and start looking at some of them and how we do linear and long and synthetic division. All right, so first looking here at synthetic division. All right, so first thing, it says here, it says find the quotient and the remainder when the polynomial is divided by the second one. Do synthetic division. So we basically are saying, this is the same as saying 3x squared minus x plus 4, and we're dividing it by x plus 2. All right, so that's just another way to write it. To start out synthetic division, okay, I like to draw with kind of like a backwards L. All right, some people draw just like a complete box, but I just draw a backwards L. Then I'm going to leave a little bit of space and draw a line across, right? And then to figure out what goes in that little box or that little backwards L, I'm going to take what we're dividing by, which in this case is the denominator, and I'm going to set it equal to 0, and I'm going to solve it, right? So set it equal to 0 and solve it. So I get x equals -2. So that -2 is going to go inside that box. Then out next to it, all right, on that right-hand side, we're going to list out the coefficients only of the numerator, all right, which is 3x squared minus x plus 4. So the coefficient of x squared is 3. Coefficient of x is -1. And then we have the constant, which is 4. In between or right before you get to that last term there, underneath that line that we drew, I'm going to draw a line down, because whatever falls on the right-hand side of that line is going to be our remainder. All right, whatever falls on the right-hand side of that line is going to be our remainder. So to start our process of synthetic division, first thing we're going to do is drop that first term down, which is 3. All right, then we're going to do -2 times 3 that we dropped down, and we're going to put that number underneath the -1. So -2 times 3 is -6, and I'm going to put that under the -1. Right? Then I'm going to add those two together. -1 plus -6 is -7. Then I'm going to repeat that process. I'm going to go -2 times -7. -2 times -7 is 14, and I'm going to put that under the 4. And then I'm going to add those together. 4 plus 14 is 18. All right, so now we just completed the entire division. Now we got to put those variables back in. So you're going to start putting variables back in with the first one being a term that's one less than your highest exponent. So our highest exponent here was the squared. So if I go one less than that, that's just a linear term, that's just an x. Right, so when I start putting these back in, I'm going to start with just an x, because x is what comes after x squared. So this is going to be 3x minus 7. Now we're going down in order based on those x's. So if I had a squared and we went one less than that, that's an x. One less than that is not going to have a variable at all, so it's just going to be 3x minus 7. And then we got to put that remainder, so we put plus 18. And then you're going to put your remainder over what we divided by, which was x plus 2. So this is our completed answer. 3x minus 7 plus 18 over x plus 2. All right, I'll do another one. Okay, this time we have x to the 4th minus 14x squared plus 5x minus 9 divided by x plus 4. So again, what you divide by is what's going to go in that little box. So I'm going to take that x plus 4 and set it equal to 0. I'm going to solve it. So inside our little backwards L, we're going to put -4. Then I've got to list out the coefficients there next to it. So I have x to the 4th, and it's the number in front of it, the coefficient there is 1. All right, notice it goes from x to the 4th to x squared. So we skipped the x cubed term. Anytime it skips a term, okay, so these all go down in order, like 4, 3, 2, 1, nothing. Anytime it skips one of those, you have to put a placeholder, which is a 0, in its place. So we'll put a 0 in for the fact that I don't see an x cubed in this polynomial. Then my next one is -14 in front of the x squared. Then we have a 5, and then we have our constant, which is -9. I'm going to leave some space, draw my line across, and then right before that last term, I'm going to put that line down because I know what falls on the right side of that line is going to be our remainder. And then we'll just keep repeating that process that we did in the previous one. So start out by dropping the 1 down. -4 times 1 is -4. I'll put that under the 0. And then I'll add those together, and I get -4. -4 times -4 is 16. I put that under the -14. I add those together. I get 2. -4 times 2 is -8. I add those together. That gives me -3. And then -4 times -3 is a positive 12. I add that with -9. And I get 3 as my remainder. So then if I start putting those variables back in, all right, our highest was x to the 4th, so that means I'm going to start this at x cubed. So this is going to be, it's 1x cubed, but I'm not going to write the 1. So x cubed minus 4x squared plus 2x minus 3. So notice again how I went down in order. I went x cubed, x squared, x, and then a constant, and then lastly put that remainder, which was 3, over what we divided by, which was x plus 4. All right, so that's how we do synthetic division. All right, these next ones are going to ask us to do long division. All right, so this is going back to kind of how you used to divide numbers when you were much younger in elementary school. All right, it again says we're dividing the first one by the second one. We do want to have, like in this one we're doing, this is what we're dividing by. I do want that to be x first, so I'm going to write it as -x plus 3. -x plus 3, because you always do want to have your x's come first, right, to go in that order. All right, to set up our long division problem, we're going to put what we're dividing by first, so that's -x plus 3. Then our division bar, like back from when you were younger. And then underneath it, we'll put our numerator. And this time the difference is we do include those x's within our problem. All right, and so to start the long division process, I'm looking at -x, and I'm going to ask myself, what can I multiply -x by that's going to give me a negative, or it's going to give me an x cubed? What can I multiply -x by that's going to give me an x cubed? Right? Well, I need another negative to make it a positive, all right? So it's got to be another negative. I have one x, but I want 3 of them, so that means I need 2 more. So that means I need to multiply by a -x squared. I can do -x squared times -x, and that's going to give me a positive x cubed. Then I'm going to do -x squared times 3. That gives me -3x squared. And then I'm going to subtract. X cubed minus x cubed cancels out. -2x squared minus -3x squared is just going to be an x squared. And then I bring down the minus 2x. Then we go through that same process again with what we have down here at the bottom. I'm going to ask myself, what can I multiply by negative x that gives me a positive x squared? What can I multiply by negative x to give me a positive x squared? Well, again, it has to be a negative number because I need two negatives to make a positive. I have one x, but I need two, so that tells me I need one more x. Negative x times negative x is x squared. Negative x times 3 is negative 3x. And we subtract. X squared minus x squared cancels out. Negative 2x minus negative 3x is just an x. And then I bring down that minus 3. Right, and the next one, same thing. I'm going to ask myself, what can I multiply by negative x that will give me a positive x? What can I multiply by negative x that gives me a positive x? Well, it's got to be a negative. I don't need any more x's, so it just means a negative 1. So negative 1 times negative x is just x. Negative 1 times 3 is negative 3. And I subtract. X minus x cancels out. Negative 3 minus negative 3 is 0. So this right here tells me I don't have a remainder because I got 0 here. No remainder in this case. So then my final answer is what you see there across the top of our division bar. It's going to be negative x squared minus x minus 1. All right, we'll look at another one here. We have 2h cubed plus h minus 2 divided by h squared minus 1. So first thing I notice is we're definitely missing some terms there. So we're going to have to put some zeros in because I've noticed that we go from h cubed down to h. So it skipped the h squared. I also notice in the denominator it goes from h squared down to a 1. So it skipped the h. So I'm also going to have a 0 there. So let's see. So that's going to be h squared plus 0h minus 1. That's what we're dividing by. And then underneath we're going to have 2h cubed plus 0h squared, because we didn't have a squared term, plus h minus 2. We start out over here with the h squared. We ask ourselves, what can I multiply by h squared that gives me 2h cubed? What can we multiply by h squared that gives me 2h cubed? Well, definitely a 2. Oops. And I had 2 h's, but I need 3, so that tells me I need another h. So 2h is what I'm going to multiply by. So 2h times h squared is 2h cubed. 2h times 0h is 0h squared. 2h times negative 1 is negative 2h. And we're going to subtract. 2h cubed minus 2h cubed cancel out. 0h squared minus 0h squared is just 0h squared. H minus negative 2h is going to be 3h, and we bring down the minus 2. And we're going to ask ourselves, what can I multiply by h squared to give me 0h squared? That would be 0. 0 times h squared is 0h squared. 0 times 0h is 0h. 0 times negative 1 is 0. And we subtract. Cancel. 3 minus 0 is 3. Negative 2 minus 0 is negative 2. So can't bring anything down. So this here is our remainder. So let's see, I have 2h up there on top. I don't really need the plus 0, right? It's not really necessary to write that, so I'm going to have 2h plus, then my remainder, which is 3h minus 2, over what we divided by, which was h squared minus 1. Right, I'm going to leave C for you to try on your own. Of course, you can always go to Moodle and check to see if you've gotten it correct. I'm also going to leave example 3 for you to try as well, okay? It is also something that you can go and look at Moodle to see if you did it correct. In number 3, it is asking you to do it both ways. Ultimately, you should get the same answer depending on either way that you do it. It does not matter, you should get the same answer. It does tell you to do both though, so make sure you do synthetic and you do long. You do synthetic and you do long for example number 3. All right, moving right along here to this last little bit. It's talking about remainder theorem and factor theorem. It says if r is the remainder when a polynomial p of x is divided by x minus c, then r is equal to p of c. Remember that when the remainder is 0, the number is a root or a 0 solution of that polynomial. Use the remainder theorem to find p of 1. All right, so if you have any number and you plug it in to that function is what it's saying. You plug it in for the x's and you simplify it. The number that you get there, that is the remainder of that function divided by basically the number that you put there. So in our one here, it says use remainder to find p of 1 for this function. So we're basically saying, what's the remainder if I did p of x divided by, in this case, this would be x minus 1, because you see a 1 there. That would be like saying x equals 1, or x minus 1 equals 0. So we're saying x is 1. That's where you get that p of 1 from. Okay, so we're doing this function divided by x minus 1. But the shortcut to this is, if you're just concerned with finding the remainder, is you just have to do p of 1, plug in a 1 for all the x's, and simplify it. And that's going to give you what that remainder would be if you actually went through that whole division process. So let's do p of 1. So that's 1 squared minus 7 times 1 plus 9. So that's going to be 1 minus 7 plus 9. 1 minus 7 is negative 6, plus 9 is 3. So we get a remainder of 3 if we were to actually have gone through that division. If we had done x squared minus 7x plus 9 divided by x minus 1, you would see that you get a remainder of 3. All right, so this is just a simple way for you to figure out what's the remainder. Purpose of this is, remember that fact that if you get a remainder of 0, then you know that that number you have is one of your solutions. Okay, that's why it's beneficial to be able to do this remainder theorem. All right, going through the factor theorem. The number c is a 0 of the polynomial if and only if x minus c is a factor of it and p of c is equal to 0. So this is basically saying what I just said before. If you do remainder theorem, you plug in that number and you get a remainder of 0, then that tells you that number is one of your solutions or your zeros for that polynomial, or it is a factor of that polynomial. Remember, all those words are kind of interchangeable. Factor, 0, solution, root. Those all kind of mean the same thing, right? So we're trying to decide, is x minus 1 a factor of this polynomial? If so, factor it completely. So we're going to use that remainder theorem to first figure out if it's a factor. We will know it's a factor if we get a remainder of 0. Okay, to start out, I'm going to set it equal to 0. So I get x is 1. So to do the remainder theorem, I'm going to plug in a 1 for my x. and I'm going to simplify it. So that's going to be 1 minus 3 plus 2. That gives me negative 2 plus 2, which is 0. So I did get a remainder of 0. So that tells me that yes, it is a factor of this polynomial. Remainder is 0. So x minus 1 is a factor of p of x, because that remainder is 0. So now that I know that it's a remainder of 0, I'm going to do probably synthetic division. I mean, if you prefer long division, you can do that. But I'm going to do synthetic division with it. Get it down to, because currently it's at an x cubed. All right, x cubes are a little bit harder to factor. It's really easy to factor things that are quadratic. So I want to get this down to something that's quadratic that I can factor it. So I'm going to do synthetic division with it. So we know we're dividing by 1, because that's what was x minus 1 that we were dividing by. I have a 1 for the coefficient of x cubed. It did skip the x squared, so I'm going to put a 0 in, then a negative 3, and then a 2. Draw my line to set up the rest of my problem. Drop my 1 down. 1 times 1 is 1. Then I'll add these together, get 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Add these together and we get 0. So you can see again, it is indeed a factor because I got a remainder of 0 there. If I put those x's back, remember we're going to start 1 less than our highest. Our highest was x cubed. So 1 less than that means we're starting at an x squared. So this is going to be x squared plus x minus 2. And I don't necessarily have to write those 1s in front of those x's there. This again is a quadratic. I think that we should be able to factor using slide and divide. We would need two numbers that we can multiply together that give us negative 2. And when we take the same two numbers and we add them together, we get 1. So multiply to give us a negative 2. Add them when we get a positive 1. I believe that would be a positive 2 and a negative 1. And so I can't do anything else more. That's as factors as it gets. So to write the entire polynomial function factored out, we had that first factor that they gave us, which was x minus 1. And then we just factored it out again, the remaining portion, and we got x minus 1 and x plus 2. Right? Which you can leave it just like that. But technically, do you see where you have those x minus 1s? You have 2 of them. A simplified way of writing this, since you have 2 of those x minus 1s, is you could just write this as x minus 1 squared and then x plus 2. Right? So both of those are answers that could be accepted for that solution to completely factor it. All right, so that completes section 2.4. Remember, go back and check those ones that you were supposed to try on your own. Check your answers in Moodle.